Welcome to Matter Video 1. In this video, we're going to start to talk about what is matter and changes within matter. So to start with, matter is anything that takes up space and has mass. And we should know that mass is just the amount of matter in an object. Since you're little, you probably have had experience with the different phases of matter, but let's just go over the key features that you should know. So first we have solids. Think about any particular solid that you would hold. Let's say like a cube. It has a definite volume and a definite shape. Liquid has a definite volume but takes the shape of the container that it's in. So we would say that liquids don't have a definite shape. So let's say you were to think about a glass of Kool-Aid. If you were to take a glass of Kool-Aid in a cup, or you were to take the glass of Kool-Aid and pour it into a graduated cylinder to measure the volume, the shape of the liquid would change. So it does not have a definite shape since the shape can change. Gas is something that has no definite volume and no definite shape. A gas will expand to fill any container it's in. So if you have oxygen in our classroom, let's say, and when we open the door, the gas flows out of the room and expands to fill the hallway. It will expand to fill whatever container that it's in. Here's a depiction of what particles would look like for each phase of matter. So you see the solid particles all the way on the left have a rigid structure. The Regents refers to them as a regular geometric pattern. They're constantly vibrating, they're close, very, very packed together. When we draw them, we need to draw them, the circles of a solid, touching and like a square. So all on top of each other, very, very close, forming this square shaped. The liquid, here, if you notice that they're close together. So sometimes people think that we have to draw the liquids really, really far apart. The liquids can actually touch. We draw them a little bit more space in between the particles than solid, which are pretty much right on top of each other and packed in. And then gases are in constant random motion. There's lots of space between them. So when we draw them, we want to draw them as far apart as we can within a space allotted. So now that we've described the distance between the different particles within each phase, we want to talk about what's the name of the process where we change from one phase to another. So some of these you probably are really familiar with and you don't even have to think about or memorize, but other ones maybe you're not familiar with or you might not even have ever heard. So you want to take a few minutes to memorize these as they will come up over and over throughout the year. Okay, so the first one, liquid to solid, is called freezing or solidification. The reason that we also use that word solidification besides freezing is because let's say you had a candle and it has wax that hardens. We wouldn't say that the candle froze. We would say that the candle wax solidified. A gas to a liquid is called condensation. You've probably seen this before, observe this in nature. Solid to liquid is melting. Again, you probably definitely have seen something melt, like an ice pop in the summer. Liquid to gas is called evaporation. Like if you have water on a table that evaporates when it's heated. Or in chemistry, we're going to use the word vaporization. So a vapor is something that's normally a liquid, but that has become a gas. So for example, water is usually a liquid at room temperature, but when it becomes a gas or becomes a vapor, it has vaporized. So evaporation or vaporization. Sublimation is when you go from a solid directly to a gas. We've seen that, you probably have seen that in Halloween, where you have carbon dioxide starts as a solid and it looks like fog or foam. It's subliming. And gas to a solid is deposition. So the phase changes we just discussed are examples of physical changes, a physical change in matter. A physical change is something that does not result in a new substance. So for example, when you melt, H2O, solid, turns into H2O liquid, it's still H2O. The composition or the makeup of the substance has not changed. It is staying whatever it was. If we had an ice pop melt, whatever it is that composed the ice pop is staying the same. So we're not making anything new, we're just maybe changing phases or changing what we look like, but a physical change does not result in a new substance. Physical property, similar to physical change, is just an observation of something that we are showing a substance is not changing. So for example, if I identify the color, the solid, something, the phase of matter, like it's a solid, a liquid, or gas, we could talk about the texture, color, size, mass, density, if something conducts electricity or not, the melting point, boiling point, if something is soluble or not. These are physical observations. Something about the nature of the substance that does not involve the substance turning into or changing into a new substance. On the other hand, a chemical property is something that does involve changing into a new substance. Here are common chemical properties that we need to know: rusting, burning, combusting, reacting, decomposing, corrosion. These are words that indicate that we have formed something new. When you burn something, you take it and you react it with oxygen and you form a new substance. This is different than heating, like typically like melting. You're not reacting it by putting it in a flame with gas that contains oxygen. Chemical change has occurred if you notice one of the following. Sometimes a change in color, sometimes there's a gas produced, sometimes you see a precipitate, which is basically like a solid that's suspended in a liquid. We're going to do a lab next week and you're going to get to see what a precipitate looks like. It looks like almost something, you'll see a solid within a liquid, so two different phases there. The key thing you need to know about a chemical change is that you're forming an entirely different substance. So let's say you're starting with water, you're not ending up with the same composition water. You end up with a new substance, maybe hydrogen and oxygen separated, but not exactly water as it was. So you're ending up with something that's different than what you started with.